1.8, more about linear equations. So last week we talked about slope-intercept form and slope, and so this week we are going to talk about some more of our linear equations and forms that we use. The first one we're going to talk about is point-slope form. Point-slope form is y minus y1 equals m times the quantity of x minus x1, where m is the slope and the values of x1 and y1 are a point. So for our first type of problem, we are going to write an equation of each line using the given information. For number 1, m equals 3/5, which is going through the point -5, 2. So we're going to substitute in that information into the formula from above. So we have y minus my y value, which is 2, equals my m value times the quantity of x minus my x value, which in this case is a -5. Okay, so we've talked about you have to show your substitution step. Now, in this scenario, I want you to leave it in point slope, but the only thing you would simplify is if you have a double negative. So if you have a double negative, we're going to rewrite it as x plus 5. For number 2, m equals 0 through the point 4, -7. Now, what does it mean when we have a slope of 0? Okay, what type of line does that create? Well, this is a horizontal line. Right? And so all horizontal lines have the equation y equals, and then there's going to be some number here. Okay. If you have a horizontal line with 0 slope, the equation is always going to be y equals some number. So let's see what happens when we substitute in those values and see what we get. So y minus a -7 equals 0 times x minus 4. Well, we get the double negative. And on the right side, I know I said to leave it in point slope form unless you have a double negative. The other scenario that you would simplify is if you have a 0. What happens when I distribute a 0? 0 times x and 0 times -4 all are 0. And the reality is, if we got y by itself, it would equal y equals -7. which goes back to the statement we had here, that all horizontal lines have an equation of y equals some number. Now, where does this number come from? Well, it's going to come through the point, right? Whatever point it's going through has to have that value in the equation. Okay. Now, I'm going to write down number 3, and I'd like you to think about it before revealing the answer, so you will probably have to pause your video. Number 3, m equals undefined through the point -6, 1. So go ahead and pause here and come up with your best educated guess of what this one will look like. Okay, hopefully you paused. Now, what does it mean when we have undefined slope? Looking back at what we had here for number 2, okay, we know with an undefined slope, we have a vertical line. Now, using context clues and elimination skills, okay, similar to the horizontal line, we have a definition for vertical lines, such that all vertical lines have the equation now in the last situation we had y equals a number. In this scenario, we're going to have x equals a number. Okay. So a horizontal line has y equals a number, vertical line has x equals a number. Now, the reality is if I substitute into point slope, I'm going to have y minus equals undefined times x minus a -6. Okay? How do we multiply by undefined? That doesn't make any sense. Okay? So the reality is it doesn't even make sense to substitute in that scenario. And so if we already know the formula is x equals a number, then my formula is going to be x equals whatever the number is going through that point, which is -6. Okay, and that's similar to number 2. You don't need to show this scenario, okay, because the reality is it will always be the same pattern. Okay, number 4. Again, please try it before moving on. Number 4, we're given 2 pieces of information, -2, 5, and -6, -4. Now, when we are not provided with slope, we are going to have to find slope. So go ahead and find slope using your skills we learned in the last lesson, and then proceed with your equation. Okay. Did you pause? Pause the video. Try it out. Okay, let's see what we get. So, using our formula, y2 minus y1 divided by x2 minus x1. On the bottom, that gives me a double negative. So simplified on top, we get -9 divided by -4. And a negative divided by a negative is a positive. So we should have gotten a slope of 9/4. Now, in this scenario, we have 2 different equations. Or sorry, 2 different points. So we could have 2 different equations. So if I substitute into the first one, y minus 5 equals 9/5, 9 fourths times x minus a negative 2, which would simplify to x plus 2. Or we get y minus a negative 4 equals 9 fourths times x minus a negative 6, which would simplify as y plus 4 equals 9 fourths times x plus 6. So because you're provided two different points, you could potentially have two different setups, but your slope would be the same regardless. Okay, and that is what we have so far on point slope form. The next form we're going to talk about is standard form. Okay, specifically IB standard form. Okay, now IB standard form is the formula capital A lowercase x plus capital B lowercase y plus capital C equals 0. Okay. Now remember, math is case sensitive with variables, so please be certain you're using those capital versus lowercase letters. Now, IB standard and standard are very similar. Standard is just simply, instead of equal to 0 or adding C, it's actually equal to C. Okay, and so this is normal standard, okay, which is slightly different than IB standard. Now, what are some rules about IB standard that we have to follow? Well, the rules for IB standard that we have to follow is that A is an element of the positive integers, B is an element of integers, and C is an element of integers. Okay. Now again, what I said up here is this must be a positive integer only. Let's remind ourselves what are integers. Okay. Remember, this is set of integers. This is our, which by definition is our whole numbers and its opposites, meaning a large array of numbers, but for A specifically, it can only be the positive integers, which is really just saying A has to be a natural number. Okay, so what we're going to do is we're going to take some information and we're going to rewrite it in standard form, IB standard form. Y equals 3/4 x minus 5. Okay, so we want to get everything on one side, and it doesn't really matter which side it is on. It can be equals 0, or it can have 0 equals at the front. Either way, in this scenario, the easiest way would be subtracting y from both sides to get 0 equals. Now when you rewrite it, make sure it's in order. Now, scenario here is that we have a fraction for A. And so in order to get rid of a fraction, we want to multiply by the least common multiple of the denominators, which in this scenario would be 4. So multiplying both sides by 4, which means every value. So 0 equals 3x minus 4y minus 20. Don't forget to multiply y and the constant. Okay, now you can write your answer or leave your answer as such. Okay, or if you prefer, you can rewrite it to where it has the 0 on the end to the right. But either answer is correct. There's no requirement to rewrite it the second way. All right, let's try the next problem. Y equals negative 2/7 x minus 1/3. So first thing we're going to do is subtract that y value, which at this point we can do without writing it. I only wrote it on the first one just so we know where it came from. And then we can multiply by the least common multiple, which in this scenario we have 7 and 3. So the smallest number they both multiply to is 21. And we'll multiply both sides by 21. So 0 equals 21 divided by 7 is 3 times the negative 2 is negative 6x minus 21y, and then negative 7 on the end. Now, we have gotten rid of the fractions. However, we still have an issue here. And remember, the rules is that a has to be positive. In this scenario, it is negative. What do we do when we have that scenario? Well, we can multiply by a negative 1. Which would give me 0 equals 6x plus 21y plus 7. Now, how could I have done this differently or faster? Okay, a couple of different methods. You could have, instead of subtracting the y to the right, you could have added these values to the left, which would have made them positive by adding them over. Another thing you could have done is instead of multiplying by 21 and then multiplying by negative 1, if you notice that you had a negative fraction, you could have just instead multiplied by a negative 21. So there's a couple different methods to getting to this answer, and this is just one of them. But in reality, there could have been a few different ways you could have done that work. Okay. Again, another option you could have done was, instead of moving y to the right, is moving everything on the right to the left, which would have just essentially done the same thing, and you would have still had to multiply by 21 on both sides regardless. The only difference here is that we would not have to worry about the negatives. So that's one method you could have done. The other method would have been by multiplying by negative 21. Okay, but either way you slice it, you're going to get that answer that we found to begin with. Now, do you have to show all three methods? No, I'm just showing it again so that you can see there are, in fact, 3 different ways you could have gone about getting the correct answer. All right, let's go ahead and see what you do on number 3 for this section. Y equals 2.8x minus 3.7. Pause and complete. Well, in this scenario, we have decimals and we want to have integers. And so when we have a decimal that is in the first position, the 10th position, that means we're going to have to multiply everything by 10. Now, before I do that, I'm going to get it set up appropriately. Now, because my x term is positive, I'm going to go ahead and move my y to the right. And now I will, in fact, go ahead and multiply by 10. So 0 equals 28x minus 10y minus 37. Okay. Now, what would I do if I had y equals 2.8x minus 3.72? Well, in this scenario, you have 2 digits behind the decimal, so that means you would have had to multiply by 100. Okay, even though this one is only 1 decimal, you need to multiply by the largest number. So, future reference. Okay, the next skill we're going to talk about is combining our skills of slope-intercept form and IB standard form. So the instructions are to write an equation in slope-intercept form and standard form for each line. So question 1 of this section. The line parallel to y equals positive 6x minus 2 through the point 1, negative 3. The line parallel to y equals 6x minus 2 through 1, negative 3. So we have to write slope-intercept form and IB standard. Now, in the scenario that we are given a point and we're given an equation. Well, we also need to consider parallel. Let's remind ourselves what it means to be parallel. If we have parallel slope, that means we have the same slope. Well, the slope from this scenario that we're provided is 6. So if we have a parallel slope, that means my parallel slope would also be 6. Okay. And again, we also know the point in which it's going through. Okay. Ooh, sorry. Okay, it's going through 1, negative 3. So we are provided slope and we're provided a point. So if we are provided a point and a slope, we have to go through point-slope form. So y minus a negative 3 equals the slope times x minus 1. Now, what am I going to do with this scenario? Well, I need to turn this into slope-intercept form. So I want to turn it into y equals mx plus b. So in order to do that, I'm going to have to distribute, which gives us 6x minus 6 and then subtract my 3 over, y equals 6x minus 9. So I've gotten my first answer, which is in slope-intercept form. Now I need to take that and put it into IB standard form. So I'm going to subtract my y, and I have 0 equals 6x minus y minus 9. And I have a positive x coefficient, and everything is an integer from there. And so therefore I don't have to do any multiplying or manipulating, and this is in fact an IB standard form. So we've answered our question. Let's try a second one like that. However, we're going to try it with slightly different. In the last example, we reviewed parallel. Now we're going to review perpendicular. The line perpendicular to y equals negative 4x plus 2/3 through 8/5. So the slope we are provided is -4. However, in a perpendicular slope, okay, with parallel slope, we knew that this was the same slope, right? But with perpendicular, if you don't remember your symbols, okay, for perpendicular slope, we have opposite reciprocal. Okay. Opposite reciprocal, meaning opposite sign, positive, negative. Reciprocal meaning if you change the numerator and denominator to be the opposite. Okay, please try to avoid the word flip. Dolphins flip, fractions reciprocate. Make sure you're using your math vocab. Okay, now what would be the opposite reciprocal of -4? Well, we know it would have to be a positive number, and the reciprocal of 4 would be 1/4. So therefore my perpendicular slope is 1/4. And again, the point we're going through is 8/5. Okay. So we're going to take our point, and we're going to take our perpendicular slope, and we're going to use the same skills we did above of going through point slope form to get to slope intercept form and IB standard form. Go ahead and complete that now. Okay, hopefully you've paused and tried this out. Let's see what you get. y minus 5 equals 1/4 times x minus 8. So I'm going to distribute my fourth. I'm going to add my 5, which allows me to get my first answer for slope-intercept form. From here, we're going to have to move on to get into IB standard. So the first thing I'm going to do is move my y term to the right. However, I still have a fraction, so therefore in this scenario, I'm going to have to multiply by 4 on both sides. Now remember, you have to write that you're multiplying on both sides. You can't multiply over an equal sign in that scenario. So we get 0 equals x minus 4y plus 12. And there we finish with IB standard form. And hopefully that is what you got. All right. Last problem like this, again, please pause and complete the problem as necessary and as needed before resuming the video to check your answer. Okay, and as always, your spacing is going to be very different than mine. Number 3, the line that goes through four, 0, and 0, 2. Okay. This is just how I write my and symbol. The line that goes through 4, 0, and 0, 2. Pause, reflect, and try this problem. All right, let's see what we get for that question. So first thing you should hopefully have thought about was finding slope. So m equals 2 minus 0 divided by 0 minus 4, which is 2 divided by negative 4, which is negative 1/2. Now there was no parallel or perpendicular, so we would have gone straight to point slope form. So y minus, now could I have picked any point from here? Yes, I'm going to go ahead and pick the first point. Y minus 0 equals negative 1/2 times x minus 4. The left side simplifies. The right side distribute. And we get our slope-intercept form. From here, I'm going to rearrange and move my y value to the right. And I'm going to multiply by a negative 2 because I have a negative fraction. So 0 equals positive x plus 2y plus 4. last thing we're going to talk about today is finding x and y intercepts. Okay, let's remind ourselves what an intercept is. Okay, an x-intercept, or plural, okay, is the point or points where the graph crosses the x-axis. So the y-coordinate is always 0. Okay, now why did I refer to points? Now, we are dealing with linear in this scenario, but we will eventually get to a scenario where we have nonlinear. Okay, a little foreshadowing for you. Okay. So if we have a point that crosses at the x-axis, like such, okay, we will have the x first and the 0 as our y value. Okay. So an x-coordinate will always be an x value and a 0. Okay. Similar but different definition for y-intercept, being the point or points where the graph crosses the y-axis. Which in this scenario would mean the x-coordinate is always 0. Okay, so if you have something cross the y-axis, it will always be 0y. Now, let's talk about what that looks like before graphing. Finding an x and y intercept after it's graphed is fairly easy. But what do we do when we are trying to find it without graphing or before graphing? So the instructions are to find the intercepts and graph each line using only the intercepts. So for question 1, we have 3x plus 5y minus 15 equals 0. So the first thing we're going to find is our x-intercept, which, a reminder, means y will always equal 0. So how do we actually show that work? We're going to substitute in a 0 for y. So 3x plus 5 times 0 minus 15 equals 0. And you guessed it, you need to show that. From here, we can simplify. 3x minus 15 equals 0. Add the 15 to the right, divide, and we get x equals 5. Now, how does that correlate as the coordinate point? Well, you got to substitute back in. So my coordinate point is 5, 0. And we're going to do the same for the y-intercept. However, x is 0 in this scenario. Similar concept, however, we're substituting in 0 for x. 5y minus 15 equals 0. 5y is 15. Y equals 3. So 0, 3 is my answer. Okay. So we show our substitution, and obviously we should show that our final answer is a coordinate point. Now, the instructions were to find the intercepts and graph each line. So we found it first without graphing. Now we're going to graph it. Now remember, graphing should always be on graph paper. So go ahead and get that graph paper out from last week when you were with me. If not, there's a package on my desk that you can grab a piece for those that were absent and did not get a piece. Okay, we're going to do a second problem. I'm going to write that here, but I need to add a piece of graph paper. So this will be from our question 1. Remember, when you're setting up a grid, you need to make sure you set up a nice clean X and Y axis. Ensuring what the heck? Ensuring that you are numbering each line and putting a little tick mark where appropriate. As you get more comfortable with graphing, this will go faster. In most cases, you do not need to do a full 10 by 10 grid, but it really just depends on what numbers you're working with. Okay. Now, if we remember, our X and Y intercept was 5, 0 and 0, 3. Now, we have the equation. We have a full equation. We could solve down for slope-intercept form, but the key here is you are solving only with the X and Y intercepts. So we are only responsible for plotting those 2 points and connecting them. So we have our x-intercept of 5, 0. We have our y-intercept of 0, 3. Do not combine those points. They are 2 separate points. And if they are not on the axes, something went wrong. Then we take our ruler connect the 2 points with a line and an arrow. And you are done with question 1 for the intercepts. Those 2 points, a line and arrows, and that is all you need. Okay, let's go back and have you try number 2. Completely solve x and y intercept algebraically and graph it. Pause the video before revealing the answer. Okay, hopefully you have paused. Okay, x-intercept y equals 0. 2x minus 4 times 0 minus 12 equals 0. Okay. Now, at this point, we can kind of double up some of our steps because we know the same thing's going to happen. We know that negative 4 times 0 is going to be 0, and we know we're going to have to solve for x. So in the same step, I'm going to have 2x simplified, but I'm also going to move my negative 12 to the right and solve. Okay. So yes, the first step is required, but we'll go ahead and shorten that second step for you, which gives me 6, 0 as my first coordinate. Then for my y-intercept, where x equals 0, 2 times 0 minus 4y minus 12 equals 0. Similar concept. I'm going to move that 12 over in my second step, and we get y equals negative 3. Okay, so your setup and answer should look like this at minimum. If you have a little bit more of your algebraic work written down, that's fine, but at minimum, this is what it should look like for your algebraic work. Okay, for my graphing, I should have copied my grid before doing my last one. Hold pause or fast forward here shortly. Okay, for those that have had me before, know that I used to be able to pause the screen, but with this new app, I don't think I have that ability. So, oh my goodness, I'm doing negatives. Let's try that one more time. I apologize, guys. Last minute video causes mistakes. Okay. Y-intercept of 0, negative 3. X-intercept of 6, 0. Connect the points with an arrow on the ends. And we are done. Complete your homework and ask questions when I return.